The different dimensions of BIM refer to a particular way in which certain types of data are linked into the BIM model. By adding more dimensions, information, you can start to get a better and deeper understanding of your project. How it will be delivered, what it will cost, and how it should be maintained. These dimensions run from 2D to 7D. Let's look at how different levels of information are added during the life cycle of the project. Lots of firms who are transitioning to BIM have the tendency to start on CAD and then subcontract the creation of the BIM model. So, basically, they pay for the job to be created twice. They deliver 2D CAD and the BIM model created separately. The chances are high that this duplicated effort will create different or even conflicting information. BIM is here to help us to not only be more efficient, but also more confident in the data. It's important to keep in mind that 3D and 3D BIM are not the same. A 3D BIM model contains 3D objects that builds up the information model. These objects represent the building or building spaces in a virtual reality. These 3D objects contain information as a minimum on length, width, and height. Other information can be applied, such as material and finish. Key benefits of a 3D information model are improved coordination, enabled visualization, and general information gathering. 3D modeling requires 3D modeling software and level of development definition. The fourth dimension refers to adding time to the 3D, often called 4D modeling or model-based scheduling. This is done by linking objects from the 3D model to a task in the construction schedule using a 4D scheduling tool like Office, Synchro, or Navisworks. This approach is changing how complex projects are planned, making it possible to visualize the whole construction project or just some phases of it, and see how timing of tasks affect the workflow. This includes comparison of planned versus actual schedules, time-based clashes, such as verifying the planned sequence towards constrained activities, like demolition, permanent construction, and temporary construction, site utilization planning, and more. A 4D model can be used at all stages of the project. During the conceptual design, it can be used to discuss site logistics. During the construction phase, it can be used to validate costs of completed work, demonstrate work to owners, provide health and safety instructions, and justify subcontractors' billings to the owner for completed work. Once a 4D schedule is set up, it requires little work to maintain and update. Then comes the 5D, the cost dimension. Added to the fourth dimension, it allows the stakeholders to keep track and analyze cost and budget over the construction and the life cycle. This includes capital costs during construction associated to running costs and the cost of the renewal or replacement. 6D BIM is the dimension of BIM that adds sustainability information to the geometric model of the building. The concept of sustainability can be split into environmental sustainability, the ability to enhance the environment, economic sustainability, the ability to generate income and employment, social sustainability, the ability to generate human well-being. In simple terms, the sixth dimension of BIM makes it possible to analyze and estimate the energy performance of the building right from the design stage to adopt technical solutions that guarantee lower energy consumption and to assess the compliance of the building's characteristics with the performance targets. The last one is 7D, the management of assets lifecycle. Used by facility manager in the operation and maintenance, this is the part where all owners want to be efficient. This dimension enables extracting and tracking relevant asset data, such as component, specification, maintenance, operation manual, warranty data, etc., and can significantly improve facility management. Regarding the last two dimensions, there's still some discussion about it. You may see on the 6D, and it may also contain the data of energy analysis and facility management. All those dimensions define the goal and the use of BIM. It's really important to define and decide which one you are going to use before starting a project. And it will provide the level of detail and information required in the BIM model. Of course, I shouldn't have to remind you that 2D and 3D BIM dimensions are not optional. But you have to have a 3D BIM model in order to be able to use the BIM process. You may have already heard about BIM levels of maturity, and you probably wonder what does it actually mean. The levels represent the BIM maturity regarding the ability to use the exchange information. They run from 0 to 3. Level 0 is basically the use of CAD, computer-aided design. It's mainly drawing using vectors lines in 2D or 3D. Let's just face it, that is not BIM, but it's a progression from hand drawing. With level 1, you start using some tools to allow you to create a smart 3D BIM model, getting information into your drawing in both 2D and 3D. But at this stage, you're keeping it to yourself and only sharing PDF or CAD version of your work. So much work wasted. If you're listening to me right now, you must be in one of those two levels. Don't wait any longer. Become more efficient. Jump to level 2. Yes, level 1 is a good step in your transition to BIM, but don't stay there too long. In my opinion, level 1 BIM is not really BIM either. So what about level 2? Here it comes the sharing, the BIM collaboration. By configuring or uniting the model from different stakeholders, it will take place in a single shared online area known as the Common Data Environment, or more commonly, a BIM platform. Guided by the BIM execution plane and supervised by the BIM manager. What could be the next step? What could be even more mature than figurative models? Level 3 envisions an integrated process hosted and fully developed through the BIM platform by all members of the project team in real time. Right now, not a big part of the building industry is focusing on level 2. There are still a lot of questions regarding the possibility of using level 3 in different fields like technology, interoperability, or contractual responsibility. Multiple associations, such as Building Smart Alliance, governments, and industry representatives, are working on making BIM more standardized and technology ready. The IFC format, for example, developed to ensure open BIM by Building Smart and supported by all countries, will become the international standard format for BIM software. IFC has been in development since the mid-90s. It was created to ensure interoperability. Today, it's a format that is not editable, but it's being used to exchange BIM data. Currently, IFC files can't be modified or saved, but hopefully it will soon be updated. So, don't be worried about level 3. focus on transitioning to level 2 by collaborating and configuring BIM models, and once you fully have a handle on it, level 3 will be just a formality. If you are interested in BIM, you probably heard of the acronym LOD. I know there's a lot of acronyms in the world of BIM. LOD stands for Level of Development. It defines for each stage of the project how deep the BIM model will be developed regarding two categories: level of detail for the geometry, maturity, and level of information for the quantity of data. This allows designers, engineers, contractors, and stakeholders to focus their work on what's needed. It's important to define those LODs at the very beginning of the project. I will explain each level from 100 to 500. There are 6 levels, and for better understanding, I will relate them to project phases. LOD 100 with preliminary design, LOD 200 with schematic design, LOD 300 to design development, LOD 350 for construction document, LOD 400 for construction, and LOD 500 for as-built projects. I want to reinforce that I am relating LOD levels to the project basis here just to help you learn them. I present them this way to help visualize the level of detail for 3D component in the model. There is no official or strict correspondence between LODs and design phases. Now, let's look at each level more in detail and use the official level of development specification developed by the BIM Forum, the US chapter of Building Smart. They describe all BIM model components such as wall, lighting fixtures, structural columns, plumbing, etc. from each milestone. LOD 100 is a concept design. The building 3D model is developed to represent the information on a basic level. Thereby, only conceptual model creation is possible in this stage. Parameters like area, height, volume, location, and orientation are defined. Let's take a look at this column. LOD 100 is a basic overall idea of the shape and no data. Just a box which may be graphically represented in the model with a symbol. LOD 200, schematic design, a general model where elements are modeled with approximate quantities: size, shape, location, and orientation. We can also attach non-geometric information to the model elements. With LOD 200, as you can see, this column that we have starts to take a shape of a steel column. This level needs to represent approximate dimensions, shape, and location. LOD 300 is a detailed design, accurate modeling and shop drawings where elements are defined with specific assemblies, precise quantity, size, shape, location, and orientation. Here, too, we can attach non-geometric information to the model elements. LOD 350 is related to the construction documentation. LOD 350 includes model detail, an element that represents how building elements interface with various systems and other building elements with graphics and written definitions. The model element is graphically represented within the model as a specific element, object, or assembly in terms of quantity, size, shape, location, orientation, and interfaces with other building systems. Non-graphic information may also be attached to the model element. In our example, at this stage, the component needs to be developed with this base plate, exact shape, and location. LOD 400 Fabrication and assembly model elements are modeled as specific assemblies with complete fabrication, assembly, and detailing information in addition to precise quantity, size, shape, location, and orientation. Non-geometric information to the model elements can also be attached. The model element is graphically represented within the model as a specific system, object, or assembly in terms of size, shape, location, quantity, and orientation, with detailing, fabrication, assembly, and installation information. Non-graphic information may also be attached to the model element. Basically, an LOD 400 element is modeled at sufficient detail and accuracy for fabrication of the represented component. LOD 500, as built. Elements are modeled as constructed assemblies for maintenance and operations. The model element is a field-verified representation in terms of size, shape, location, quantity, and orientation. Non-graphic information may also be attached to the model elements. Basically, LOD 500 relates to field verification and is not an indication of progression to a higher level of model element geometry or non-graphic information. It is simply an as-built model. So, earlier I said that level of development can be related to project phases, but remember that officially they are not. It just helps to picture the milestone. There is actually no such thing as LOD 300 model. It doesn't make sense to require the same LODs for all objects in the model. I know it might seem easier, but you will lose too much time detailing objects we don't really care about. For example, I need to know there's a table and a chair in the room. I don't need the exact location and the shape. Given this, LOD 100 is probably enough for this chair and table. So, defining LOD is not a project milestone, but rather a model component definition method. Here's my opinion. It's not so much about using those official LODs. I mainly use it as a guide. What's really important is to define, according to BIM use, project phases and delivery, the level of detail and information for each object, and as soon as possible in the process. You wouldn't need the same amount of information regarding analysis, simulation, visualization you want to run. This way, it will allow you to efficiently build your model that fits your budget. Otherwise, you could spend a lot of time making everything in detail.